in many ways, this is an easy introduction. All of you know Jim well. Most of you at least know him well. I've worked with him for many years, either in the laboratory or in the department or in this university. There's no need, as Dave said, for me to enumerate his career in detail. He's going to talk about it. But I'd like to introduce Jim and his talk from a personal perspective a little bit. When I went to Arizona State University in 1969 as an undergraduate with a vague interest in science, I took my first chemistry class that fall from a young assistant professor named Mike Parsons. And he turned out to have been Jim's 10th PhD in 1966. And Mike was a great teacher and influenced me a lot as an undergraduate. And when I asked him about what to do after I graduated, he said, well, there's no choice, you have to go to Florida. Jim Winefordner, and I did. I had never been east, grew up in Arizona, so I got my car and drove to Florida and arrived on New Year's Day, I started in the middle of the year. And I remember the first time I met Jim when I found Lee Hall and I went up to his office there in the corner of the 3rd floor, and I was very timid and knew his reputation to be very large and didn't know what to expect. And as everyone else has said this afternoon, I was welcomed like a long-lost son, and I was immediately taken into the group and felt immediately at home. And it's a characteristic you hear over and over and over again from all the students and postdocs and people who are members of the Wine family, which is known as the Winefordner group. I'm very proud and happy to have been a member of it for such a long time. I stayed around, obviously, and I was his 42nd PhD. And a few months ago, we had the final defense for the 160th. And when students who are remaining in the group finish, we'll be into the 170s PhDs, which is, that's a phenomenal number in itself. Anyone in an academic career who produces 170 PhDs has done something right. And then when you add all the master's students, the postdocs, the visiting scientists, the hundreds of undergraduates, which Jim has always encouraged in his lab, and then not to mention the probably 10,000 undergraduates who he's lectured to in quantitative analysis and instrumental analysis. It's an enormous, wide-ranging influence. And just to wrap up, I'd like to put his position in perspective as to where Jim came from. You're all aware that he got his bachelor's, master's, and PhD at Illinois at a very prime time working with Howard Momstad. And I really view Howard Momstad as the most influential analytical chemist of the 20th century. He had an enormous impact, and it's partly a confluence of good timing and being in the right place at the right time. The 1950s was a transition point for analytical science, where we went from many, many decades of classical wet chemistry doing bulk analysis, and people doing refinements on that general theme of improving analytical methodology with traditional methods. And with the invention of the transistor in the 1950s and the electronic revolution that followed, Howard Momstad catalyzed that kind of science and focused on what it could do in analytical measurements. And Jim was lucky to be there at that time and to be caught up in that revolution. And his career, the last 47 years, really spans a complete revolution in analytical science, from that wet chemistry and bulk analysis to our current methodologies, which are focused on single cell measurements, single molecule measurements, chemical measurements on single atoms. It's been an exciting transition. It's been a revolution in the science, and Jim has been a major influence in that transition. And I think today he's going to give us a nice overview of what it was like to be a part of that change. Jim?
Thank you very much. This is almost totally overwhelming to me, and it's hard to live up to what he said without a doubt. So I'm I feel very thankful for all the things that people have said, and for the people who have come here to hear this talk. So first, I'd like to thank Dave and Ben and Nico for all arrangements for this particular chair's lecture, and particularly Ben and Nico for all the support they've given over the years. I'd like to also thank the three speakers who were here and gave wonderful talks, and I feel very honored that they would be here in Jose and Ed. And also, I would like to thank all the people who came from large distances to be here. I guess the furthest distance is Prague. Prague, thank you for being here. So, today I'm going to give a kind of a review of where I've been and where things are and where things are going. And this gives me an opportunity to review just the general topics of research. You're not going to hear much of any science in this other than just the general topics, but it gives you an idea of where we've been throughout the various years. It gives me a chance to indicate some of the things, the accomplishments we've made in my group over the years. It gives me a chance to thank, or at least acknowledge a few of the people, and I must say I can't acknowledge everybody, but I will point out a few people as I go through, and I don't mean to slight anyone. And so I hope you'll get a feeling of kind of, well, it says 45 plus, and by the way, I gained 5 years from PitCon. There was 40 plus there. So, and now it should be really 47 plus. So, so it's going to be talk since 1959 when I arrived here. And I'm going to do it. There's sort of a summary of the whole ball of wax, so I guess you could all leave after this. I got all my degrees at the University of Illinois under Howard Malmstott. And I'm going to divide the talk into periods which are not the same length of time, but indicate certain productivity in those years in certain areas of research. So these are the 8 periods. And the general theme is, which has already been mentioned, has been signal noise, growth curves, or maybe calibration curves. Fundamental calibration curve. Fundamental parameters of flames and plasma, atomic fluorescence, possibility of radius, spectroscopy, and the rest of the other. And as Ben said, actually, I think we've been 161 PhDs, there should be 11 more. There's been over 100 postdocs and research scientists, and about 30 more masters, which I have up here in the number of publications. And the number, the years of various grants I've had now over the various years. So this is, we're going to go through this, and first I'll cover the so-called pre-UF period when I was at University of Illinois. I entered there in 1950. I got a bachelor's degree in 1954. I worked for Howard Malmstott with high-frequency titration, and actually had a bachelor's dissertation, or thesis, I guess it's called. And then I got a master's degree in 55 on molten bead AC spark spectroscopy. And then I left school for a little while with the crazy idea that I should join the Army. And that was the day of the last days of the Korean War, I guess, the Korean War period. But never got inducted, so I came back after a semester or so lapsed and got my PhD degree in 1958 in the area which is a lot of you know, because some of you may be surprised at. It was electrochemistry, and called low point potentiometry, and that was a very hot topic at the time I was at Illinois. Yet Howard was doing various low point techniques. And I thought I'd put up this first, for some of the colleagues I had there were Harry Purdue, who went to Purdue, valedictorian, I think, with the University of Alabama, Birmingham. And when Mr. Haziwani went back to Greece to a university, a lot of Howard's first students went into industry. And only one of the publications is shown down here. I'm going to show titles of publications so you get some idea of the kinds of things that went on. So, okay. Nothing fancy on my PowerPoint. I'm just lucky to be able to show PowerPoint at all. The two main influences I had there, and I think Gary and Will had the same, was Herb Lightman, who was there at the University of Illinois for 34 years, head of the analytical division, and also came here and was here for 17 years before he died. Was an incredible scientist, and actually a little bit scary at times back in the days. But once he got here, he was much more mellow, but he was a tremendous administrator with respect to graduate students. And he actually, at that time, did not allow any two analytical students to interview for the same academic job. So I'll say something more about that. And this is Howard Malmstott, who was an incredible scientist in person, and at one time, out of his first 40 or so graduate students, I believe about 20 went into major university teaching. Not all of them ended up there, but I think that he has changed spectroscopy just by the way his students populated the spectroscopy area and made a tremendous difference in analytical chemistry, particularly analytical spectroscopy in the United States. Okay, period one, when I was an assistant professor and I got promoted in 1965, I'm going to give a bunch, I'm not going to point all this out, but on each one of these period slides, I'm going to give a number of graduate students, a number of postdocs, and you can see I didn't have very many back then, number of publications, the group size, the space, you can see it's not very much. You might notice it's just going to go up and back down, but anyway, it's around 250 to 1,000 square feet. And I had funding, some early funding from NSF and NIH and AFR during this period. But just notice that I felt very lucky to have $5,000. Now, if a new faculty member starts out and gets less than 500 to 1,000 to $1 million, it feels slighted. And inflation hasn't gone up that much. I mean, sure, it hasn't gone up. So, but I thought the anarchy was bad. Major research areas were low temperature phosphometry, atomic fluorescence, so the noise ratio of temperature effects, and atomic emission and absorption. And here's something for the people here who are in the Department of Chemistry. Our analytical division there, well, when I came in, it was pretty non-existent. In fact, that's all I'll say about that. Armin Gropp was the dean of, an assistant dean of the College of Liberal Arts and Sciences, and he had a couple of students, and I pretty well took care of his students at that time. So he was here when I came. These other two arrived later. He came in and then left shortly after that. And Gerhard Schmidt, of course, a lot of you know, electroanalytical chemist. Kurt Kramer was a co-part at GC. He came in, I think around 64 or so, 63, and was here until over 5 years ago. Okay, let me just explain. Dave said something about Harry Sisler. This is, of course, Harry Sisler. And I feel very fortunate. When I came here, I stayed at the old Hotel Thomas. And when I woke up, came out that morning to talk, nervous as hell, kind of like I am today. Came out, flowers were blooming everywhere, and I thought, boy, this is the most beautiful place in the world. I mean, it was this time of year, so the azaleas were going. It was just a wonderful place. And my interview was terrible. I mean, to this day, I don't know why I hired it, because everything just flopped. I mean, my talk was bad, my interviews were bad, but some way or another, and I don't know the whole story of this because most of the people have left the university or here at the but they hired me, so I feel deeply indebted to their system. Oh, and I might mention something else. When I graduated Illinois, I said Herb Lightman watch very closely where you can interview in an academic position. And 3 of my colleagues, one went to Princeton, one went to Penn, and one went to Harvard. I went to Florida. It looked like I got the short end of the stick, quite frankly. But guess what? All 3 of those other schools wiped out analytical chemistry within 5 years. And here, analytical chemistry has been extremely strong ever since almost I arrived. So it's never been any talk of getting rid of it. Some schools did back in the 60s. I always show some pictures. Many of these have been shown before. This is one of the early pictures. This is when I was a little bit younger, of course. This is Ben Carson that Ben talked about, but much later in the 1980s. He had to read that so much earlier. And this is Pablo Haber, which was mentioned, and Howard Lasser, my very first PhD. Okay, here we start. I mean, I'm just giving this, by the way, I apologize to people who went to Pittcon Talk. There's some differences here, but I gave this pretty much the half of the awards at Pittcon last year in Orlando. Anyway, just give you an idea of the kinds of things that went on and the people involved. Tom O'Haver, who was at the University of Maryland for many years, was very influential in pulse, and Gary talking about this, pulsing technique. Tom Vickers, who was at Florida State, I think he just retired very recently, he got involved with the first of the atomic fluorescence study, and the limits of detection, which was an extremely kind of, at that time, a very innovative approach to calculating limits of detection. Analytical chemists always kind of thought, I think at that time, the best limit of detection was the lowest you could pick a graduate student can see, and man, they can see low values. We don't have any criteria. So we got involved with what determines the limit of detection in atomic spectroscopy, particularly emission absorption. And then Bill McCarthy, one of the brightest students at that time, went to the University of West Virginia and died within 5 years from a heart attack. He was a tremendous scientist. And of course, Leo Gaylor, incredible first postdoc. The second period, 1967 and 1971, you can see, as we go through here, you can see the group sizes really increase, and at one time, I even got 26 people at the time, my spaces increased up to 3,000 square feet. I had 29 straight years of NIH funding, and I've had other 5-year grants. So, I don't know if that's a record, but that's a pretty long time to have like one grant from NIH for all the renewals. And I had Air Force Army to do flame diagnostics and this type of thing back in those days. Postdocs, publications, and so on. I got the Mayor's Award, which is actually my marks at that time. High spectroscopy article. The academic division now consists of Roger Bates, Kravitz was still here, and Gerald Schmidt. And these are the areas of research which you'll see again as we go through it. Before I go further, let me just explain there were 2 other extreme, well actually 3 extremely useful scientists who had a great effect on my life. Elmer Fassel from Iowa State was the premier atomic spectroscopist at that time and remained one of the premier atomic spectroscopists almost up to the point that he retired. He was a tremendous scientist and had a lot to do with the use of ICP emission and ICP mass spectrometry. And he was very nice to me and helped me out through the years. Keith Alperman is a physicist from Utrecht University. And he and Nico and Ben and I have worked together for many years with him, and it's just a tremendous collaboration. The person I don't have on here, I mean, I think there's some kind of a pecking order, and you oftentimes think somebody who doesn't have a PhD isn't really maybe necessarily all that bright. One of the brightest people I ever knew was Paul Gilbert at Beckman Instruments. And he had a tremendous influence He had just a bachelor's degree. And he was a tremendous influence on me in the early days of calculating detection limits. And he had a better idea of what's going on than any other scientist, I think, in the world at that time. And another scientist that had some indirect effect was Heinrich Kaiser from Germany, who was the guru of analytical figures in America. And this is me in my early days when I looked like a terrorist. Most of you won't even appreciate this picture because of Lou Owens and Fred. But well, I thought that was not what I think Jerry knows what I'm thinking about. Anyway, now fundamental parameters of atoms and flames was really a hot area for us. We got into measurement in calculation of the free atom fraction, in several papers here, measurement of Damping constant, which is essentially the ratio of Lorentzian to Doppler, or collision of the Doppler broadening, several papers here, and more on the free atom fraction and dissociation energies. All these were fundamental papers in which some of them involve experimental verification or work with it. And then thermal equilibrium flames, Leo Galen and Pete Zayers from Alabama's lab, was involved in several of these papers. Bill McGee was down in Central Florida, and Pete Zayers here again in Signal and noise became a very important area. When you talk about detection limits, you got to talk about signal and noise. When you talk about precision, you got to talk about signal and noise. So as a result, we got really involved in signal noise almost throughout my entire scientific life. We've been involved in signal noise ratio experimentally, but also theoretically. How do you predict what the signal noise is? If the signal noise is predicted to be very poor, why are you going ahead with the project? So, and then growth curve to shape approximately the signal versus the number density. And Mike Parsons is here. We worked on the intensity as a function of atomic concentration and atomic fluorescence, atomic emission, theoretical and experimental growth curves by Pete Davis. And here's Rocky Svoboda, who's one I think we were involved with. Critical, this I don't think at the time had ever been done, critical comparison with atomic techniques. And this was a very extensive article. Time resolved phosphorimetry, I think we were one of the early ones that actually got into doing time resolution in phosphorimetry, which obviously is much easier because the lifetimes are much longer, milliseconds per second, but nevertheless we got into that back in the mid-60s, the late 60s. And then we were, I believe, the first analytical chemists in the world, and one of the few that had any lasers. So we got involved with, we got our first laser back in like 1970, I think, 69, 70, and there was a nitrogen laser, and we were certainly the first on campus to have one. And I'll say one thing, at one time we had like 80, in my lab, we had 80% of the lasers in our lab that were on campus. 80% of the lasers on campus were in our lab. Now we have maybe 0.5%. So it's really changed. Then the next period, 7 years, and you see the number of PhDs that students and postdocs have grown drastically, and so on. And I was very fortunate in 1973 that the American Chemical Society in Analytical Chemistry, which is the highest award in analytical chemistry, and I felt very fortunate because 2 people nominated me independently. One was Roger Bates here at the university, and the other one was Howard Malmsteen. And then there's the Pittsburgh Society SAS Award and the ACS Instrumentation Award. And these, again, are the areas, not looking at the divisions, grown. We had non-time going through the growth and provided for Roger Bates. And now these pictures I think I've been showing before. I've taken a year here. This is Nico and me when we were younger. I acted like I was doing some work. I became totally incompetent to do experimental work about 2 years after I went on. I had a group size that I didn't need to do it, and so nobody would let me alive anyway. This is a group back in 1977. Still have my full beard. And this is a group in 73 and 79. I won't go through trying to mention everybody, but you can see some of the best bands they were. Okay, I want to bring up this slide here that Gary showed it too. At the 2004 PitCon, some of the Mollenstadt Scientific Family, I mean, it'd be humongous if everybody came to it, because Howard, I think, only had maybe 56 or 7, maybe 8, I don't know, somewhere in that order, PhDs. But because so many of the students went into big universities, Indiana, and Purdue, and Michigan State, and so on, a lot of big universities around the country, the production of scientific offspring was incredible. And so this is just some of them that came to that meeting, which was Gary and some of the others you may will recognize. But I will give Howard credit for generating or producing the people, the scientists, the spectroscopists, that ended up going to university and really changing spectroscopy in analytical chemistry in this whole country, maybe in the world, but certainly in the United States. Okay, another slide. Now we're doing a lot of laser excited fluorescence of atoms and molecules, and I won't mention Nico again because they're going to be in a lot of it. You can see that there are a lot of papers involving atomic and ionic fluorescence and molecular fluorescence as we go through this, shapes of analytical curves, which is something that calibration curves, which I mentioned before, comparison of continuous wave and pulse continuous sources for atomic fluorescence. This is now a laser, this case right here, and the pulse nitrogen laser in molecular fluorescence. And all these were back in the 1970s. And we continue all the work we do on flames, calculation and measurement of the radiance of atomic fluorescence and the properties of flames. And if you go down here, you'll see there are many fundamental papers, more theoretical ones on the radiance expression, experimental verification of saturation of laser excitation of flames, molecular, we did some work on molecular species with Hiroki Hawaguchi from Japan, Rick Browner, who's at Georgia Tech University, did a lot of work with flame temperatures. This was a valuable technique for rapid measurement of flame temperatures, and it worked very well. And atomic fluorescence, well, this is this is about a 200-page Bible at that time of atomic fluorescence. Multi-element techniques. Back in the 70s, most things were done by single element measurements. In other words, you measure one atomic atom line at a time, or one molecular, one spectral bandwidth of a molecular band at a time. But we got, there were some multi-element techniques, so it would be wrong, but we were really interested in trying to make atomic fluorescence into a multi-element technique, but this is still doing one element at a time. There was a slew scan or a sequential technique like Mary was mentioning earlier, but it worked very well. Frank Planky and Dave Johnson. We got involved very early with image detectors, but we didn't keep it up, which is too bad. And we got involved with computer-controlled atomic fluorescence and emission technique at that time. And then we had a variety of work on pulse time resolve phosphometry, and phase resolve, which is a real hot area now in doing fluorescence lifetimes. But one thing, but much more sophisticated. More on phosphometry. Here, Juan Boudin, who was the peer here, tremendous scientist, one of my postdocs in the kind of middle years. You can see in 77, 76, 77. He went to Oak Ridge, he did extremely well, and he's just accepted a position at Oak Ridge, at Duke University. It's a $50 million Biophotonics Institute, and he's heading it up there. And he just started March 1st, so he could not come. We got involved with a number of instrumental studies involving particularly these two here, the preparation and evaluation of electrode discharge sites. These are lamps we put into a microwave field and they emit light very nicely and usually very narrow conic line. We also got, I think, we're one of the first to get into hadamard spectrometry in the UV visible region, which is not the, hadamard has been used for many years in the infrared region, particularly for astrophysical studies, and double modulation of fluorescence. And a little bit more on instrumentation, selectively modulating the barometric technique, which was, I think, a really clever technique that John Fitzgerald worked on. It was a strange case with John. He finished about 1976 and got his PhD degree in 1987 or 88 or something. And he was going through some kind of divorce or something, had to leave town in a hurry, and I didn't know until he came back. Coerced him into coming back that he had any problems at all. So he came back out of PhD much later. Double modulation, this was, a lot of people are doing this now. We did it back in 72, and Carl Boudin worked on image detector SIT back in the day. Signal noise and statistical methods, we've been always involved. Ed gave a wonderful talk on statistical techniques for detection of it. And some of this is a little bit field from that. Information theory, tied to analytical chemistry, comparison signal noise ratios for a bunch of different techniques, theoretical comparison of signal noise ratios of Fourier transform, microscopic interferometers, in other words, with single slits, linear spectrometers, comparison of pulse sources with continuous wave sources. And so we were involved with trying to compare a bunch of different techniques on very uniform set of criteria. And in period 4, you can see the years, there's only 3 years in there. The group size has increased again, and I was fortunate to get a couple of awards during that time. But the endocrine division now has increased to the anatomic was added, and Katie Williams came in at that time, and Nisha Young. So our endocrine division is, you'll see, gradually grows to the point where it can't put the first name to it. Again, this picture was shown, photo was shown by Ed. And this was a group back in 1982. You can see the other categories. And once again, let me just, I don't want to spend a lot of time on this. In fact, what I'm going to do is just measurement of flame temperature. This is an extremely important area, not only analytical chemistry, and if you say not only flame, plasma temperatures is an extremely important area in science. Combustion research and plasma spectroscopy and so on. And so we have several ways of doing it. George Ortiz was deeply involved in this, and John Bradshaw and several others. And then Ed mentioned one of these papers here, which was wrong. We were interested in limits of detection, what determines them. I mean, how is it defined? Because still there were a lot of random definitions of detections. And we also got measured noise power in an ICP at that time, and that was, I think, a paper that caused some interest in the world. Saturation and rate equation calculations. We did a lot of basic. You can see here, this is pretty well spearheaded by Nico, but and Court Van Dyke, who was up at Georgia Tech, were involved in it. And then atomic, it was very interesting. In atomic fluorescence, you have to have a light source to excite an atom or an ion. And then you have to have something to produce those atoms or ions. And one way, the way it's normally done is you have atoms in the flame, you hope, or in a plasma, and you send a light source in, and you excite those atoms and make fluorescence. Well, back in 1980, Mike Epstein was using an ICP, an inductive chemical plasma, which was mentioned in the earlier talk, as both the excitation source as well as the cell, the atomizer or the ionizer of the analyte. I'm using Inman here, he spearheaded this whole area of constant energy synthesis method. It worked out extremely well, and then you can see at Wakeman, he and Ben were dual postdocs in my group, and they pretty well, they had a tremendous influence. They pretty well ran the group in terms of keep track of students, and Ed was involved in many projects at Framework at that time, and Ed's major research area turned out to be two photon polarization detection of a variety of things in liquid chromatography, HPLC. And he combined polarization with photoacoustic detection and also fluorescence, and it was a combo type detector that worked extremely well for HPLC. This period, another 4-year period, I ended up being a teacher scholar at the University of Florida in 83, 84, after the year. And you can see the funding here in the space now is up to 5,000 square feet. The group size is pretty big. And some of the awards include the ACS Chemical Division Award. And the other division here, I think it's essentially the size of the one from the last one. Some group members here, and you can see the group size is reasonably large. And again, we go back. There's measurement of flame parameters. I'm not going to go through all this, but measurement of flame parameters by a variety of techniques. Using things like fluorescent dip spectroscopy, thermally assisted high fluorescence, measurement. I became very interested back in these days to measure absolute concentrations of species by technique. Everybody who does analytical chemistry knows you always run standards. That's the way you do it. Well, what if you can't get a standard? Wouldn't it be nice if you could just get a signal and convert it to a concentration? Obviously, that's very, very difficult, but we were involved in that back in my graduation then, back in the late 80s. Laser-excited atomic fluorescence in furnaces. These are electrothermal atomizers. You put your sample in, you can dry it, you ash it like a blood sample, and then you can raise the temperature very high, 2,000 degrees or so, and form atoms. Once these atoms are formed, you can excite them with a laser, and this is what all these projects involved here, is laser-excited atomic fluorescence in a graphite furnace. And at the time we were doing this work, we had some of the real best detection limits, but now and Gary talked about some of this, a lot of detection limits by ICP mass spectrometry are just incredible. And so whether any of these techniques can actually live up to those is perhaps doubtful. And then we were involved in the comparison of techniques again. review. More work on synchronous luminescence, which, of course, Eugene Newman started, and polarization of liquids that Ed Whiteman and Tony Malone and several others were involved in. Time result possibility down here, Glenn Barnes. This is, I think, one of the real premier areas we were in at that time. And then during this time, back in the middle, the late 80s, we got involved with surface enhanced Raman spectrometry and got some extremely good results that were of great interest at that time. One of the problems I think in academic research is sometimes you don't get the continuity. It's not like being in a government lab where you keep getting money in a certain area and you keep students keep going into that. The money dries up or the student interest dries up, the project can. So we got involved with coherent form scatter and recurrent spectroscopy, instrumental improvements. This is diffusion resistant, flashback resistant diffusion burner we used back in the day. And this is what one paper they talked about studying time variant filters for analytical measurements. And so, signal noise again. Okay, we're getting up close to the present time, but in period 6, I've now got a large lab, a large group size, a lot of funding at that time, a few more awards, and these, again, are the areas, these are the people here in analytical chemistry. Maybe, I don't know if Dave was on the last one now, but I didn't mention Dave Powell. Now this picture here, you might find it interesting, was taken, at one time I had the whole second end of the second floor where the chair of the Department of Chemistry office is. That whole area that was completely open then. And I think we went into Montebelle's area and we took a picture back in those days, and it must have been about 35 people there. And it was very hard to see everybody because of all the equipment, and people had to find a place to stand. 1990. Again, more surface mass Raman. Javier Serna from Spain was involved in that. Since then, he's been primarily involved with LIBS, laser-induced breakdown spectroscopy. Brad Jones, who is at Wake Forest University, did an interesting study on using a moving cooled belt to get Sapolsky matrices in fluorescence. Double resonance fluorescence, again, something that I repeated before, fluorescence dip spectroscopy, and again, a lot of papers in that area. Chris Stevenson was involved in some of these studies. I'll mention him on the next one. Laser cytokine fluorescence in furnaces and flames. Many more papers in that particular area, many more studies in that area involving the excitation of atoms, some in flames, but most of it we were interested in was in graphite furnaces at that time. And fingerprinting of polycyclic aromatic hydrocarbons in the environment. Tony Malone was here, and he was involved in that one. Okay, this is what I wanted to say. We got very involved after the first study that came out of Oak Ridge and out of Russia, Leathercalls and who's the guy? Oak Ridge. Hearst. They published some papers. They were both physicists. They published papers on single atom detection. Now I want you to realize that single atom detection is not single atom measurement. There's a big difference. Because when they did single atom detection, they detected one atom in a cloud of other atoms, so it wasn't exactly what you call single atom measurement, but it was very exciting to So we got involved in a number of studies. How close can we come to the single atom detection and measurement? And then we did some work on diode. We got involved with diode lasers back in the late 80s, and they became extremely popular and labeled in spectroscopy. We did some work on residence line lasers, and details on that. Micro's interferometer to do UV visible spectroscopy, and more on the UV belt detector that Brad Jones had worked on. And then we get up to 91, 96, and the number of people are PhD, a lot of PhD, a lot of good average group size, and space, and a lot of grants at that time, and a number of awards. And I'm very proud of this. I had a special issue dedicated to me back in I'm not sure which year it was, but anyway, and this is Nico's title he came up with, Individual Search for Innovation in Analytical Chemistry, Spectrochemistry, and a 640-page issue of this journal. And again, the annual revision, Bob Kennedy's going to have it at the time. The group that way was shown here. A lot of pictures don't have the entire group size, but anyway, group members there. And again, we go back in our research to absolute number densities, trying to measure things without standards. And we have several papers on that. We got involved with laser ionization spectroscopy. Laser can come into a flame or a cell that will cause ionization, and you measure the current produced, or the electron pair produced by measuring the current. And so a number of papers on that. And here is a series of papers which are, I think, just wonderful that Chris Stevenson carried the ball on this. And he did some wonderful studies on how we can link principles of accident detection quality and atomic spectroscopy, how many atoms and molecules with lasers, and so on. These were, I think, really mainstay articles at that time, and I think these probably still are. Double resonance, this comes back to haunt us again, fluorescent dip spectroscopy, and Joe Simmons was involved, Giuseppe Petrucci, and then Ovid Motley, who's I think here in the audience. These are all papers that involve double resonance or fluorescent dip spectroscopy. Metal vapor filters. Rami Enderling is in the audience. This is something that's actually been quite interest to a lot of scientists in the country for the scientific community. This is, we use the metal vapor filter to reject, laser scatter and single molecule detection. This is Ralph Bernard. This is one of the early papers on single molecule detection in liquids. And two more papers down here on single molecule detection. Microwave spectroscopy, we do a lot of work on where you place the sample is introduced into a microwave plasma and the emissions measured, and a variety of microwave plasma papers, most of them applied. And then comes the final period where now you see the group size smaller, numbers of square feet smaller, some spaces less, and various the awards. Very happy with the CSI award in 2003 and the Hassel award this past year. And now John Otto is a member of the division, Charles Powell is a member of the division, Jack Martin, a member of the division. And a couple more pictures are taken in 2003, 2001, and that's the way I feel it was comfortable wearing that kind of stuff. And this is final group, although Kirby there as well, but this is the final group of my academic career. Other than Nico. And Ben, who's there? I don't know who's there. Okay, and then I'll go rapidly through this. Laser ionization spectroscopy, cavity ring down spectroscopy, we do all of both. The cavity ring down is to do particulate matter in the atmosphere, modeling the Lewis plasma. This is really Igor Yanushkin's fine work. The laser-induced breakdown spectroscopy, many papers in this particular area, but again, Igor has been one of the driving forces in this, and Dave Kahn from engineering has worked closely with us on the variety of projects. And resonance ionization fluorescence imaging was a pet project of Owen Mate, and then we had several outstanding graduate students, Tiffany Correll, Nathan Pixley, and Dimitri Pappas, were all involved in these projects and all got dissertations. And we're on just more, a lot of papers in this particular area. And you can see what we published, a lot of them paper journals like optics, communications, and applied spectroscopy, applied optics, and so on. And this is a get together we had in 2001, I think was the right date, of some of the people from the CAST group. Here's Juan, you can come to this meeting that we on. This is Howard Lax, who died a year or so ago. He was my first PhD. Okay, to finish up, I've got a couple of just general slides, and I've given this out in some form or another over the past 40 years or so. And this is sort of my wishes we provided to the group, and you can read it. I'm not going to go through and read each one. I think that there are pretty good guidelines to go by. If I've gone too fast or anything, I'd be happy to give you a copy if you want to see it. Just rapidly, this is all the countries, and a lot of some. Every time I publish this, I have a little newsletter, every time I go with group members, every time I publish it, somebody says I've missed some country. Okay, two final ones. One, these are my philosophy and things that I feel very strong. Teaching is more than just going to lecture. 2 or 3 lectures a week. It involves many hours of interaction with students. I think you can't teach unless you interact with students. And when I first came here, I taught 2 courses every semester. Didn't even mind it. I mean, that was the way it was. And I've always taught one semester, 1 course every semester, except when I had a sabbatical 1 semester. And I've always been very negative on, I think anybody who's at a university, who's a part of any department at a university should be teaching. And they should be teaching about research. It's much more than just a publication of grant. It's the developing of graduate students and maturing. I agree, I've been very lucky. I had Dan and Nico, and then Goyman, Nico, and Rusha, who would want to help out. But it's really, I mean, it's more than just and service. It includes committee work and so on. I've been division head for so long, I'm not even sure how many years I've been. Of course, it was by default. When I came in here, there was attention going on like a chemist, so why wouldn't I be division head? And so now, okay, the final one is Howard Malmstott. Special thanks to Howard Malmstott, research advisor at the University of Illinois, Herb Lightman, feature advisor at UI, Roger Bates, a tremendous scientist, colleague at UF. Roger, Herb, and I really, I think, began the modern analytical chemistry division. I really want to give a special thanks to Ben Smith and Nico, been here, well, the first two have been involved with research and group for more than 25 years, actually close to 30. And the others of the order of 10 years. And I'm really indebted to all the senior scientists who have been in my group, the graduate students, which total around 200 students, and the postdocs, which are around probably 120. A group of people indebted to all these people. And I've had some 200 undergraduates. I look at track of them. I'm really indebted to Jeannie Terribly, the analytical division secretary for 27 years. She's given me great advice and done a job with excellence, but she's kept me out of trouble all these years. And that's I deeply appreciate it. Thanks to the U.S. administration, all the past chairs, and deans, and I've been involved with, especially also provost and the president, Brian. And last but not least, thanks to my family for supporting me all these years. Just being here. Thank you.